In the previous two videos, we managed to use Haarcascades to detect faces in images and videos. So today I wanted to see if I could do something with object tracking. After all, that's much cooler than just detecting a face, plus I've got some really cool ideas of how we could use this tech in some future videos. For example, at some point when I can afford to move out, I think it would be awesome to build dummy from Iron Man. The idea would be to have two cameras, one for recording me and one for doing the object tracking, and it would follow me around the room, and I think that would be pretty cool. Anyway, today what I wanted to do was see if we could combine what we learned in the last two videos, so using Haarcascades to detect faces, and I wanted to see if we could combine that with object tracking. So I actually did find a fairly good article on PyImageSearch, and this goes into quite a lot of detail into how to actually implement object tracking. Now the only thing with it is the way we're actually choosing what we're tracking, which is cool, but it's by using the mouse. You probably saw it at the beginning, so we kind of select an area, and then once we're happy with it, we hit space and then we track that. What we want to do is right off the bat see if we can detect a face, and then once we detect that face, we're going to track it. So that's what we're going to do. So we follow that tutorial on PyImageSearch, then eventually we'll get some code which we'll go into in a moment, which does the following. So we're starting the video stream now. This is me, and if we hit the key S, it allows us to select an area. So right now I could choose my face, for example, and then we hit space. Now it's a little bit laggy, but it's pretty good. It actually follows us around. So this is one part of the code we've got, and then in a moment I'm just going to go over what we had before with the Haarcascades. So if you watched my previous video, then we actually were doing real-time face detection using Haarcascades. And I'm about to run that script in just a moment. It's pretty laggy, because what we're doing is every single video frame we're looking for eyes and faces. I should probably get rid of the eyes bit, but I'm just going to leave it in for now. So I called this, so the Python script is just called cvid. And we're going to execute it now. It's going to be really laggy. It's much worse than the object tracking, but essentially what we want to do is we want to hack, in quotation marks, the object tracking program we've got, and instead of actually selecting an area, we want to use this Haarcascade. So in a moment we're just going to be looking at some code. So we know what we want to do now, and we've identified all of the pieces of the puzzle that we need in order to achieve our goal. So let's get started and actually implement the code. So just before we start, we need to make sure that in our resources folder we've got the frontal face XML file, which we used in the previous video. I'll leave a link to where you can download that, or you can just watch a previous video and follow that along. So we want to make sure we've got that. We're then going to open our editor, and the file I'll be working from is this OpenCV object tracker. I need to make my file names shorter. What did I do? Oh, I didn't actually open it with a text editor. So if we open that up, and what I've done is, again, so we did a real-time object detection using the Haarcascades, and all I've done is actually copied and pasted that into the object tracker program. And again, the object tracker was a tutorial I followed on PyImageSearch, but I'll put the modified code on my website, so you'll be able to get everything there, and a link for that will be in the description too, if you're interested in following along. So I'm not going to make any modifications just this second, but we will do in a moment. We don't actually have to do much, so this is great, but I'm just going to talk you quickly through what's happening in the whole code. So if we just ignore this stuff for now, because this is our Haarcascade while loop, I'm just going to scroll down to the first segment of the object tracker. And what this is, it's just a command. These are command line arguments. So the lines from here, which is 42 to 48, all that is saying is there's going to be two command line arguments. By default, if we don't choose a tracking algorithm, then we're going to be using the KCF, and there will be a link in the description also to all the OpenCV trackers. And then we've also got an argument for video, and by default we'll see in just a moment, if we don't specify a video path, then it's just going to try and access our webcam. So then following on from this, we've just got a dictionary of the different trackers, so you can look all of these up, but again there'll be a link in the description. Our default one is this KCF one. Now I can't remember the difference between them. Some of them are better, some of them are faster, so it really depends what you're trying to do. We'll probably be using CSRT, I think I had good results with that, or KCF, but again it doesn't matter right now. Then next, here we're saying if we don't get any args for video, then what we're just going to do is we're going to grab our source 0, which is usually a USB input or your webcam. Otherwise we're going to use the video that's specified in the command line argument. So then we're going to be starting our main while loop. So this is going to go on continuously until we decide to quit. So this is good because if we're tracking a video, we obviously want it to go on continuously. And here we're going to grab our frame, and here if we don't have a frame, we're literally just going to break out of the whole while loop, and then we'll just quit. Then after this, we're resizing our window that we're going to be displaying for people to see. So the actual video feed is going to be resized to a little box with a width of 500. So we're then going to skip this initBB, which stands for initialize the bounding box, and that's because we haven't really defined it yet. We'll be defining that in just a moment. So we're just going to skip that on our first loop. Let's scroll down a little bit. So here we're showing our frame. Then here we're waiting for a key, and this is the bit we're interested in. If you remember me I think I said at the beginning of the video, it's when we push the button S. Well, this is the way the code is written here. When we detect the letter S, that's when we draw our bounding box using our mouse, and then that for us defines our initBB. And all this initBB is, and we're going to see that in a moment, is just the coordinates of the bounding box we defined. So it's just it's just a list where we've got our x, our y, our width, and our height. So all we really need to do is hack or hijack this bounding box, and here we're going to be putting our Haarcascade face detector. So instead of returning the box we've defined, all we're going to be doing is returning the coordinates of the face that we detect. So this is kind of the key part for us, and I'm going to keep it inside this if key equals s. We can always get rid of that if we wanted to, but it just means you click S, and then we'll find the face, and then we'll get started. And then here our tracker then gets initialized with our frame and our box coordinates, and from that on we're tracking that box. So that's what we really want to achieve. Then of course if we click Q, then we break out of the video, out of the while loop. And then this is just the standard stuff that we do at the end. We release everything and we destroy all windows. Then if we scroll back up to here, our if statement initBB, which was our initialize our bounding box, if it's not none, so essentially if we have it, then we're going to go into here, and we can see that in this if statement, this is where we update the frames with our tracker. And if it's successful, I think here we're actually drawing the rectangle again, so this obviously we're redrawing it. You're updating the frames, remember, you're not physically moving anything, it's kind of an illusion, but you know that. And then here we were printing some information on the box and displaying it using this for loop here. So that's it in terms of explaining what's going on. Let's just make the few little small changes that we spoke about at the beginning, and then hopefully everything works. So we literally just grabbed everything from the previous video we did, and I literally just brought it in here. So we need to actually go ahead and tidy up this code quickly. So of course we don't need this import CV2 because we've already imported it above. I've already said that we'll not be dealing with eyes, so there's no point in having this eye cascade. On top of that, this path has changed. The path is now just resources. So it's resources Haarcascade frontal default XML, so that should be good. If you remember, we're actually defining, I'll have to find it now, down here somewhere, we're actually capturing our video stream with VS, and that grabs source 0, so we no longer need this capture. So we'll get rid of this too. Something else, just to tidy up for the sake of this particular program, where it says scale factor, I'm actually just going to write the number in, so that's going to be 1.05. If you don't know what these terms are, I recommend you watch my previous video, or the video before that actually, the one that's 30 minutes long or so. That actually has a pretty good description. I have a blog post on it too. And then, again, we're not doing anything with eyes, so here we were detecting a face, and then when we detected a face, we would look for eyes within the face. Let's see, eyes, we don't need that, and this was a bounding, this was also used for the eye, so we only really care about drawing this rectangle, or finding the coordinates of this rectangle. So when we find the face, we draw a rectangle, this is going to give us our coordinates, so we do want this. We don't care about this, we're already showing our image later, we don't care about any of this because we can click Q to break out of our loop. Now we do care about this because this is actually what detects our face. This is the Cascade detect multi-scale, and we still want to convert our image to grayscale before doing anything. So again, we also want this. I can get rid of this comment. We will be using a different frame, a different image, so we don't care about this, and we don't care about this, and we don't care about this because we've moved it over to this side, and we won't be caring about this. No, we do care about the while loop actually, I think. So that's everything we're going to need. I think I'll probably leave the Haarcascade at the top just so people know, that just so it's easy to know that that's what's being used. And all we need to do now is actually, we're going to play around with it. So what I'm going to do now is I'm going to turn off the webcam because the program's going to be using the webcam, so I can't record at the same time as using it with Python program, at least as far as I know. So that's what I'm going to do. So I'll see you in a moment. So just quickly before we do anything, it probably makes sense to actually run the program. So I'm going to comment out this just to make sure everything is actually working. So if we quit out of here, so we're going to run a Python script by saying Python 3 and then declaring our file OpenCV object tracker.py, and then we're saying for our tracker argument we want CSRT. We're not going to give a video line, but you would do that like this, video, and then you'd give a file name, for example. So we're going to see if this works. Hopefully we've got no. So we're starting the video stream, and there I've appeared on screen. Let's sort my hair out quickly. And then supposedly if we click S, everything pauses. I grab my face, hit space, and then we can actually follow my face around. So what we want to do is hit S and then our face gets detected. So I'm going to quit. So we saw that everything worked fine, so we're going to go back to our code now, and we're going to play around with a couple of things. So we're back in our file now, and what I wanted to do quickly is just show you what this initbb is. So we're just going to print it. And again, like I said, it will be just the rectangle coordinates, and what we're going to do now is we're going to run our Python script again with the CSRT tracker, and when the camera comes on in a moment, you'll see me, all is great, and when I hit S, I'll pause and grab the face, and then we can see in the bottom left corner here we've got this little tuple. Hang on, I'll leave that on the screen. And this actually gives us our X and Y coordinates in terms of the top left corner. So this is 37, and then this width here is 102, and then we've got a width of 258 and a height of 294. So that's what these values here represent. So let's go back to we know that now. So we know that all we have to do is basically hijack this box. So let's quit. So we just go back to our file quickly. Let's see what the last command was. Yeah, let's go back to our file. And notice I did make a quick change. We had this for loop where we were drawing the image, but actually we won't be drawing the image because we just want the coordinates. So you can just make sure that your code looks like this quickly if you're following along. Otherwise it doesn't matter. So what we wanted to do is, I think I'm going to grab all of this like so, and then we're just going to take it and we're going to go down to this S here. We press S, Control Y, and what we're going to want to do is a couple of things. So I want to print out for you what this is going to look like. So we already know that this init BB, we grab a frame and we get a tuple of our coordinates and whatnot. So we want to emulate that, as I said before. And what I'm going to do is I'm going to actually make this list called faces. And faces is just going to hold hopefully just one, but it'll possibly be more. And rather than saying while true, I'm going to say while length faces is less than 1, because we just want to detect. It's a bit of a what I'm doing is a bit of a trick, really. So if you remember in the previous video, what the object detection does, actually, it's constantly refreshing and constantly looking for new faces, and we're still doing that with this while one. We could just do it like once, and we could just detect one face, but we're going to do it like this anyway. And we're just going to grab the first face that we detect, and then we're going to track it. Hopefully it's our face. Right. So while length faces is less than 1, we're going to grab our frame, make sure that this doesn't say image like it did before, make sure it says frame, and then this is going to detect our faces, and we're just going to add to the list. So what we want to do now, I think, is just print. We're going to print faces down here. I think this is going to work. And what we're actually going to do as well is we're going to print init BB. I don't know why I got rid of that. And let's see what happens when we run our Python script this time. So here I am. We hit S, grab the coordinates, and what we see here at the bottom left is our tuple. So this is the coordinates we're currently using for our what's being tracked currently. And then this is our list of faces. So we've actually detected 2 faces for some reason. Now if we look at these coordinates and these coordinates, they look pretty similar. So I think our first place here is probably our actual face, and I don't know what's been detected here. So what we're going to do is we want to grab that first face, we want to convert it to a tuple like this, and then we're going to replace it with init BB. So let's go ahead and do that. So I'm just going to quit out of here, and we're just going to literally go back to our program, scroll all the way down to where are we? S. This is where we want to be. Now we're no longer going to be using this init BB. So I'm just going to comment it out though. I'll probably remove it. Actually no, I'll keep it in. I'll keep it in. So faces. Now we saw we wanted, it was a list of lists, right? So what we actually want to do is we want to say, we don't want to change anything else because we're still grabbing init BB. So we're just going to call it init BB, and that's going to be equal to let's see, our tuple. Remember, it was in the form of a tuple. That's what it's going to want. And then we wanted what's that? Faces position 0. Assuming it should exist. So assuming we detect a face and our face is at spot 0, this should now work perfectly once we hit the S key, and we won't be doing any of the dragging. So let's see if we've got any errors. So here's our face, and we're just going to hit S. So there, it's detected our face, and now it's tracking us around. So that's kind of cool, and that's pretty much it. Now we could play around with, seems to be getting smaller and smaller. Well, there you go. Sometimes I have a bit of fun of it. I think if you go off screen, you can kind of, oh, it detected me again. It doesn't always detect you again though. So I'm probably just rambling a bit now. Something else we could try is, that's not what I meant to do. That's kind of cool. That's not what I meant to do. We could try a few of the different algorithms, sorry, different trackers. So if we go down, there's a few. I believe the MOS one is really fast from my memory. I can't tell. We've got CSRT, KCF, and MOS. Let's try out a couple ones. I'm going to go with the MOS one. That's supposed to be really good, or fast, I think. So let's do that. And I'm going to look at the camera, and I'm going to hit S, and we've got our face. It's actually lost it already. Oh, there you go. Boom, 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 boom. CSRT, we could try. So let's quit. No. KCF. I think it's called. hit S, and again it's found us. So that's it basically for today. I have just been rambling for the last couple of minutes. You've probably already left. I'll make the code available on my website. I probably won't alter it too much, but what's really fun is you can just kind of get in here and you can just, you know which bit you need to alter now to detect something. You don't need to use the mouse. Maybe you've got a face detector, maybe you've got an eye detector. All you have to make sure is that you just need to make sure that you get it in the form of that tuple with 4 and obviously it has to be the correct order. It has to be X, Y, width, height. So as long as whatever object you've got is doing that, then you should be good to go and you should be able to do whatever you want. So if you like this video, then check out my website and maybe like and subscribe, and thank you for watching.